Hello and welcome to David King's Discovery, where we take a look at an animal from the present or the past. In today's edition, we will be looking at a dinosaur that's captured the imagination of experts and the public since its discovery in the 1850s, Pachycephalosaurus. Often a favourite amongst the paleontologists and the avid dinosaur lover, even if you didn't know this animal by its name, it is almost certain you would have seen them in some sort of media. They have appeared in multiple movies and TV shows and documentaries over the years, instantly recognisable with its distinct dome-shaped head. As I'm sure of a lot of people, my first introduction to this animal was in Jurassic Park 2: The Lost World. The large domed head animal instantly ingrained itself into my mind, and the more I have learned about this creature over the years, the more I have fallen in love with it. So join me as we take an in-depth look at the history of this animal. What was this animal like, where it inhabited, and most excitingly, what was that domed head used for? As well as some other interesting facts and discussions going on about this animal. First, let's take a look at the interesting history of the discovery of Pachycephalosaurus. Due to the process of fossilization requiring very specific conditions to occur, Pachycephalosaurus fossils, like other dinosaur fossils, are very rare. Currently, there are only a few partial skeletons discovered, but there are more well-preserved adult skull fossils. Due to the lack of complete skeleton fossils, it is hard to determine the specific details about the growth and behaviour of Pachycephalosaurus. As well as the limited number of fossils, Pachycephalosaurus has a complex history in regards to its own fossil discovery. The name Pachycephalosaurus was first coined in 1943. However, fossils we now know as Pachycephalosaurus were previously thought to belong to other species of dinosaurs. For example, a fossil once thought to belong to a group of dinosaurs called Troodon, a relatively small bird-like theropod, were re-examined and found to belong to the newly coined Pachycephalosaurus in 1943. The first official Pachycephalosaurus fossil discovered was in 1860, where fossil collector Ferdinand van der Veer Hayden discovered a small single-bone fossil, and in 1872 Joseph Leidy described a new dinosaur from a fossil, Tylosteus ornatus, believing the fossil to belong to an armoured reptile-like creature. Whilst the fossil was definitively identified as a dinosaur in 1928 by Charles Gilmore, it was not until 1979 where the fossil was once again re-examined and discovered to actually be the squamosal of a Pachycephalosaurus, a bone at the rear corners of the skull, found in most reptiles and amphibians. Pachycephalosaurus lived towards the end of the Cretaceous period, between 70 and 66 million years ago, making him one of the last non-avian dinosaurs to exist before the mass extinction. Pachycephalosaurus lived in what is now North America. Fossils have been found in Montana, South Dakota, Wyoming, and Alberta. The habitats that Pachycephalosaurus roamed were most likely warm, humid woodlands and floodplains. As an interesting side note, Pachycephalosaurus would have been one of the few dinosaurs to have lived in the same time frame as grass, which only evolved around 66 to 70 million years ago. You might be asking yourself, if Pachycephalosaurus fossils are so rare, and no complete skeleton has been discovered, how can we determine its size or behaviour? The answer is that we use information we know about more well-documented Pachycephalosaurs, such as Stegosaurus and the more closely related group Ceratopsia, to make educated assumptions on the behaviour and size of Pachycephalosaurus. Whilst Pachycephalosaurus was a medium-sized dinosaur and by no means the largest dinosaur to ever exist, it was the largest Pachycephalosaur known to exist. The estimated size of Pachycephalosaurus is that they stand between 4 to 7 feet tall and are 15 feet long, weighing between 370 and 490 kilograms. Pachycephalosaurus most likely had an S or U-shaped neck, with a thick, wide-hipped body with long legs. Like most dinosaurs, it also had 3-toed feet, with short stocky arms and 5-fingered hands, with claws on 3 of the digits. Pachycephalosaurus most likely also had a very thick, heavy tail that would be extremely rigid. Whilst the body of Pachycephalosaurus can only be estimated due to the lack of fossil records, we have very well preserved fossils of its skull, allowing us a much clearer view of the facial structure of this animal. Incredibly, just the skull of Pachycephalosaurus can reach up to 2 feet long. Pachycephalosaurus had a short face with large, rounded, forward-facing eyes, giving them good binocular vision. As well as having good eyesight, we are able to presume that Pachycephalosaurus also had a very good sense of smell. Research has been able to show that Pachycephalosaurus had large, divergent olfactory lobes, with large nerves and large, robust olfactory bulbs, giving Pachycephalosaurus a very good sense of smell. The top of the skull would have been bone up to 10 inches thick, with bony knobs and spikes around the rear. Whilst it is completely accepted that Pachycephalosaurus ate leaves, fruits and nuts, there is some debate whether insects or small reptiles were also a part of their diet. This hypothesis is based on the fact that Pachycephalosaurus had teeth that were small and serrated like that of small theropod dinosaurs, which could be used to eat small prey items. However, it is important to note this is only still a theory, with very limited studies or fossil availability to support this claim. Like most other dinosaurs, the colour of Pachycephalosaurus is unknown, due to the fact that soft tissue of animals, which helps researchers determine the colour of animals, very rarely fossilizes. This has led to Pachycephalosaurus being depicted with a wide variety of colours in the media, from dark green and brown to being highlighted with blues and reds. The dome in particular has been shown as either almost bare bone or multicoloured. Whilst we may never know the actual colour of Pachycephalosaurus, it is always interesting to see different depictions of this wonderful animal. In every depiction of Pachycephalosaurus, from movies like Jurassic Park and The Land Before Time to documentaries like Prehistoric Planet, Pachycephalosaurus has always been shown with headbutting behaviour. Even when the designs themselves are almost unrecognisable, the one constant is Pachycephalosaurus headbutting something or someone, even to the point where he has been shown headbutting King Kong in his own animated TV show. Whilst these depictions in some media have been clearly dramatised in both design and behaviour, the core concept where Pachycephalosaurus would headbutt each other or other animals has been a source of constant debate and research. Before delving into the main theory of the dome, I think it's important to highlight some other believed ideas of what the dome was used for. One theory proposed was that it was used for thermoregulation, similar to theories about the sail of Spinosaurus or the plates of Stegosaurus. Another common alternative theory is that the dome was part of a mating display, with the domes being decorated in bone structures and coloured to attract mates. Both of these theories do not have the level of research conducted as the headbutting theory, leading to little or no actual evidence for these theories. The idea that Pachycephalosaurus butted heads can be seen as early as 1955, where paleontologist Edwin Colbert theorized that the dome-shaped head of Pachycephalosaurus was used as a battering ram, similar to modern-day mammals such as the bighorn sheep. A study conducted in 1978 argued that Pachycephalosaurus had specific attributes, such as ossified lateral walls of the brain case, which were designed to distribute impact stress from the dome to the body. In 1997, Kenneth Carpenter conducted a study looking at whether Pachycephalosaurus would target the flanks of other animals instead of the heads of other animals. It was argued that the size and shape of a dome would have maximised the pain inflicted by hitting the flank of other animals, whilst also protecting Pachycephalosaurus. This idea is also supported by the fact that Pachycephalosaurus most likely had thick bodies to help protect their vital organs during competition with other Pachycephalosaurs. Carpenter's study also disagreed with the previous assumptions that the body and neck of Pachycephalosaurus would line up in such a way to provide maximum distribution of stress. Looking at other dinosaurs such as relatives to Pachycephalosaurus, it was argued that the neck would have been in the shape of an S or a U, instead of straight, which was the thought at the time. The neck being in the shape of an S, or in the shape of a U, would lead to extreme stress being put on the spine during headbutting, as it would cause compression and damage to the spinal discs. Furthering the argument against headbutting is a study by Goodwin and Horner conducted in 2004. Analysis of the bone in the skulls found that the previously thought spongy tissue that was used as evidence for headbutting was more likely to be growth tissue in younger specimens. Furthering this was the comparison of Pachycephalosaurus to modern animals that headbutt. Bighorn sheep are often used as the comparison, but have adaptations not found in Pachycephalosaurus. Adaptations such as broad heads, with large impact areas and even air-filled chambers in the skull, which help reduce the strain and stress on the sheep's body, reducing the risk of injury. Meanwhile, Pachycephalosaurus has not been found with these adaptations, and rather than a large area, the dome would have had a small area of impact, which some argue would not be suitable for headbutting. Countering this argument, however, in a 2007 study found that the domes of Pachycephalosaurus were in actuality built to withstand and dissipate high impact forces from the top of the head. Both domed skulls and flat-skulled Pachycephalosaurs showed these results. One argument used against the idea of headbutting was the fact that the skulls of Pachycephalosaurus lacked any visible damage that would be present if the animal did engage in such behaviour. It wasn't until 2012 and 2013 where studies by Peterson looked at Pachycephalosaurus skulls and found evidence of this behaviour. A CT scan of the skull of Pachycephalosaurus found 2 large depressions caused by trauma, as well as osteomyelitis, which is a bone infection caused by trauma. To further this research, Peterson in 2013 examined other Pachycephalosaurus skulls and found that 22% of the specimens had lesions on the dome, which increased in concentration towards the top of the skull, indicating consistent trauma and recovery on the domes of Pachycephalosaurus. Having looked at all these studies and the ideas presented, in my personal opinion, it is likely that Pachycephalosaurus did indeed engage in headbutting, or at very least, flank-butting behaviour. However, I can see it also being likely that the dome was used for mating displays, similar to how deer horns are both used to attract a mate and also settle territory or mating disputes. Maybe I'm also just being nostalgic, having seen Pachycephalosaurus headbutting in some of my earliest childhood memories, and it being one of the first things that I remember about this animal. It is likely that we will never know the full answer to some of these questions, but one thing is for certain, and that is that Pachycephalosaurus has arguably the most unique and striking attribute found amongst any dinosaur. The dome of Pachycephalosaurus is not the only source of controversy stemming from this animal. As previously stated, fossils are re-examined all the time, and sometimes these fossils once believed to belong to one species are instead found to belong to another. This has been the case with two Pachycephalosaurs, Stygimoloch spinifer, the horned devil from a river of death, and Dracorex hogwartsia, the dragon king from Hogwarts. Two species with two of the coolest names in paleontology. Both are no longer considered by some to be their own species. Rather, they are younger versions of Pachycephalosaurus. In 2009, Horner and Goodwin examined the skulls of all three species and found that the age of the bones in each species did not overlap. All Dracorex fossils were that of juvenile animals, Stygimoloch fossils were that of subadults, whilst Pachycephalosaurus fossils were all adults. A further study conducted in 2015 by Goodwin and Evans found anatomical similarities in the skulls of Dracorex and the youngest known Pachycephalosaurus. Whilst the evidence for Dracorex not being its own species at this moment is pretty conclusive, there have been some disputes whether Stygimoloch should be reconsidered to be its own species or not. In a recent study in January 2025, it was put forward that all Stygimoloch fossils have only been discovered during the final 500,000 years of the Cretaceous period. The fact that these fossils are only found in the latest possible timeframe and not earlier like some Pachycephalosaurus fossils show that potentially Stygimoloch was its own species. However, it is important to remember just how uncommon fossils are. This makes it hard or even impossible to make definitive conclusions based on the geographical locations of fossils. That's all for this video. I hope you have managed to learn something new or interesting about this unique animal. I hope to see you again soon.